I'm Jake with SendCutSend. Welcome back to our series on the technical side of bending. Every day, SendCutSend bends tens of thousands of parts, so we know a thing or two about bending. So let's get into it.
Check it out.
All right, on lesson 6, we're going to be going into different types of reliefs that you need to have on your sheet metal parts. So if you haven't seen lessons 1 through 5, go ahead and check them out, because a lot of this information is not going to make sense until you understand those lessons in particular. So going over here to the board, right, we're going to be talking about reliefs and why we're going to want to do them and what they are, right? So let's start talking about why are they important and what they are. In a bend, right, if we have a part that's bent, I have a lot of parts here on the desk, when we bend it, and we've talked about this in the deformation videos, we've talked about this in like the stretch on bend allowance, is that we have tension across the outside of that bend. I have a little thing here. So on that bend, we have that tension across here. That tension equals stress. And that stress has to go somewhere. And if we have too much stress, then we get a couple different reactions, right? We're gonna get cracking and tearing, right? And so we're gonna end up seeing that material split through it. We're gonna end up seeing it tear, crack later. Sometimes you don't see it initially when you first bend it. We're gonna have cosmetic issues. So one of the big cosmetic issues that you have when you don't have that relief is a big dimple in your corners. So if I have a 90-degree corner here, what we're gonna end up seeing with a non-relief is a big dimple up in that corner. And then the last thing is that it really does affect the CNC brakes. So that increased stress has to go somewhere. It typically goes back into our tooling, and we see premature wearing and stuff, and sometimes breakage of tools if not properly done. And so we try not to necessarily bend parts that don't have reliefs. Now, how does it work? So it's pretty simple, right? We're just gonna be removing material in that area that stress is building up, so it allows it to breathe, and that breath that it has now allows it to shape, and we're not gonna crack, we're not gonna tear, you're gonna have a better cosmetic finish to it, and it is obviously easier on our tooling. Now, there's a lot of different ways we can do it, right? So when we talk about types and designs, you're gonna see people do square corners, round corners. There's ways that you can do essentially a straight line in on your corners, as well as bend reliefs. You can do half circles into your part. That is kind of up to you, and it's gonna be a little bit more dependent on the design and the finish that you're wanting with your part. And so that one we're gonna kind of skip over a little bit. I just kind of recommend, if you're using Fusion 360 or SolidWorks, or even just Googling this information, you can kind of see different ways in which you can do the reliefs. What we're gonna focus more on though is the difference between a bend relief and a corner relief, and how to make sure that you have enough room in the background there. So, bend reliefs, we're gonna go over first. And so bend reliefs, we're gonna come in here tighter, is if we have a straight line like this and we have a corner that's getting bent over on that straight line, what it is it straight cuts into the part. And so I have a part here. This one doesn't have reliefs here. We can see stress that's built up in these corners here. We will see tearing eventually on that part if you don't see it already when we do it. So now, how do you know how much relief to put in, right? So we need to know how wide to make that, how long into the part to make it to properly relieve that stress that we're talking about. And the rule of thumb, this is what you're gonna see on our website and our guidelines or on the material settings, is to make that width, the size of that slot, half that material thickness. And then additionally, how far into the part that we want to go is going to be the bend radius plus the thickness plus 20 thousandths is what we recommend. Now, Fusion 360, SolidWorks, a lot of the popular CAM softwares, they're going to do a lot of this math for you. It saves you a ton of time. I typically recommend just going with what they have. I've never had any issues with it. Okay, next is corner radius. So corner reliefs, we're gonna end up putting in on two 90-degree corners, like this one right here. If I match it up with a mating part like this, what we end up seeing is those two 90-degree corners come in here. I got stress that is pulled this way and stress that is pulled this way, and that kind of results in a little dimple or a raised area here. Cosmetically, it's not appealing. And then also additionally, it tends to crack and tear, especially on the inside of your part. So what you end up doing is you can either do a round shape, like I said before, or a square shape, pretty much anything that essentially brings back that whole entire radius into that, relieving that stress in that deformation area. And so from the bend line into the part, the equation that we're going to use in the background is the material thickness minus the bend deduction and half of the bend deduction, and then you're going to add 15 thousandths to that. Again, the simplest way is having Fusion 360 or SolidWorks do this, but if you are going to be doing your stuff on your own by hand, know that that is an equation that you should use to be successful on your parts. All right, so that's it for lesson 6. To get pricing on your parts, drag or drop a step file or DXF onto SendCutSend's website, and always check out that merch store. Thanks for watching. Stay tuned for more.